This is the lesson on solubility equilibrium, which is associated with dissolving a salt in water to form an aqueous solution. I will explain everything in step by step, so hopefully there won't be any confusion. Soluble salts break out into ions when dissolved in water. A salt is considered soluble if more than 1 gram can be dissolved in 100 milliliters of water. If you can understand this simple topic, then you are an AP Chem baller. The process of dissolution requires two aspects. 1. The solute, which is being dissolved, or the solid, which is this. 2. The solvent, which is doing the dissolving, or a liquid, which is this. If you memorize that, then an 8+ is something which you won't miss. The key mathematical concept relating to solubility equilibrium, which we'll be discussing today, is solubility product, or KSP as it is most commonly referred to. I know this sounds complicated, but if you listen to me, then you'll be more successful in AP Chem than Napoleon was at Waterloo. KSP is a measure of the extent of a salt's association in a particular solution. Now let's move on to the mathematical expression. When the reaction is... The expression for KSP is... What KSP tells us is how well a salt dissolves in water. Insoluble salts have a low KSP, while soluble salts have a high KSP. If you use this formula correctly, then you can destroy your next AP Chem test just like Bruce Lee.
What the KSP formula means in non-mathematical terms is that the concentration of one product, which is capital A in this case, is raised to the power of its coefficient, which is lowercase a. This multiplied by the concentration of the second product, which is uppercase B, raised to the power of its coefficient, which is lowercase b, gives the KSP. In some cases, the coefficient may be just 1. In this case, you don't do anything to the concentration. Some cases it may be 2 or 3, where you square and cube respectively.
Now let's apply this concept to a real-life example. Let's say that the reaction is... And we know that the concentration of chromate is 1.3 times 10 to the negative 4, while the concentration of silver is 2.6 times 10 to the negative 4. The equation for KSP is... And if we plug in the values, we get 8.0 times 10 to the negative 12 as our KSP. The KSP of a reaction can also be used to calculate the concentrations of the products. Let's say that the reaction is... And we know that the KSP is 200. The equation for KSP is... And since the moles of copper and iodine are equal to each other according to the reaction, the built-in equation for KSP would be KSP equals x squared, with x representing the concentration of both products. If we plug in the values, we get 14.1 as our concentration. To sum everything up, soluble salts dissolve in water and they split into ions. A salt which cannot absorb any more water is considered saturated. At this point, chemical equilibrium is achieved. The KSP equation tells us how soluble a salt is, using its molarity as a mathematical foundation. Hopefully after watching this video, when you encounter solubility equilibrium, your reaction won't be, what in concentration?